Hello students, how are you? I think you are fine and well, doing your job properly. So today we will start next portion of this chapter, lecture number 2, class 10th maths, chapter name circles. And we will start what introduction we have taken. So I will solve first. Then after this, 2-3 example given, one activity given, we will try to understand them also. If you can understand these, so I think no problem. Till here what we have done, if a line touching the circle at only one point, that one is known as the tangent to the circle. Yes or no? And another is what? Another is this, if a line segment or line cutting the circle at 2 points, so that one is known as secant of the circle or chord of the circle. This also we understand. Diameter is the longest chord of the circle. We understood what is segment, what is sector, and what is chord, and what is arc, what is circumference, and if circumference of circle is 2 pi r, why it is 2 pi r. This I told you. Now we will start next part of it. So what's given? So this is, check one time, this we have to, one theorem we have done, the tangent at any point of a circle is perpendicular to the radius through the point of contact. And point of contact is that point where this tangent and radius meeting with each other. Understood? So this theorem also you understand, the tangent at any point of a circle is perpendicular to the radius through the point of contact. So now this, how many tangent can a circle have? How many tangent? If we are having a circle, what is that? Circle. So how many tangent we can draw? Infinite. Because circle is made up of from the infinite point which are equidistant from a point. That point is known as the center of the circle, and this is known as the circumference of the circle. So how many tangent you can draw like this? From one point you can draw like this. So saying like this also possible, this also possible, through this point also possible, through this point also possible. How many point on the circle? Infinite number of point on the circle. So what we can say? How many tangent can a circle have? Infinite. Understood? Next, fill in the blanks given question number 2. A tangent to a circle intersect in how many points? You know, 1 point. How many points? 1 point. And if cutting more than 1 point, means 2 points, then it's becomes secant. A line intersecting the circle in point is called secant. And this also you know, tangent is a special case of secant. Understood? What's its another name? Chord. And diameter is the longest chord of the circle. A circle can have parallel tangent at the most. So we are having this circle, and we have to, one tangent is given like this. So how many tangent we can write? So we can draw this. One tangent. A circle can have parallel tangent at the most. 1. So what's coming? 1 parallel tangent to the most. Or we can write this also, 2 parallel tangent at the most. So these both are parallel to each other. The common point of a tangent to the circle and the circle is called the common point of tangent. So like this and this coming. So what's the name of this point? Point of contact. Point of contact. Understood? In introduction I told each and everything. Then question number 3 given, a tangent PQ at P of the circle, radius 5 centimeter, meet line through the center O at point Q, so that OQ equal to 12 centimeter. Find the length of PQ. So try to understand. We are having what we are having? A tangent. What we are having? Tangent. A tangent PQ at point P of the circle. This is the point P and this is the circle. Center of the circle. This radius is 5 centimeter. A tangent PQ at point P of a circle of radius. This meet a line through the center at point Q. So Q is taking here this join like this. So this is 12 centimeter. OQ, this is O. OQ equal to 12 centimeter. Find the length of PQ. You have to find out the length of PQ. So what we can say? In triangle, which triangle? OPQ. Angle OPQ is equal to 90 degrees. So this is a right angle triangle. If it is a right angle triangle, we can apply what? Pythagoras theorem. So perpendicular square plus base square is equal to hypotenuse square. So this angle is 90 degree. So definitely this is hypotenuse. Understood? Which one base? This one we can take base and this one we can take perpendicular. So what's OP square plus PQ according to PQ square is equal to OP square plus is equal to OQ square minus OP square, and two lines parallel to the given line. So we can draw one line like this. What we can draw? We can draw one line. We can draw one line, and what we have to draw? One is tangent. One is tangent to the circle. So what you can do? You can make here 90 degree angle here anywhere. This 90 degree angle. And same 90 degree angle here and draw like this. Or this 90, alternate angle between two lines are equal. Its meaning line are parallel. Similarly, what we can draw? You can draw here also making 90 degree angle. Here also you can make how much degree? Sorry, here how much? 90 degree. Draw this line. So this is a, we can say PQ. This is RS and this is XY. So here XY is parallel to RS and RS is parallel to PQ. So all are parallel to each other. PQ is parallel to RS, is parallel to XY. So understood? So in this way we can solve this exercise. Now next. So this activity given to you. What's activity? Draw a circle on paper. So you can draw a circle on paper. So this is a circle. Take a point P inside it. So we have taken, you know, this plane is divided by this circle in three parts. One is this inside the circle. Another one is the boundary of the circle, and third one is the outside the circle. So three possibilities are there. So first given, take a point P inside it. So P point we can take inside anywhere inside this circle. Here I have taken. You will find that all the line through this point. We will draw line which passing through this point. So like this we can draw. Another we can draw. Another meaning how many line we can draw in this way? Infinite number of line we can draw from this point. But all line what happens? intersecting the circle at how many points? Intersecting the circle at 2 points. How much you want, you can draw. How much line possible? Infinite number of line possible. But all cutting the circle at how many points? 2 points. You will find that all the line through this point intersect the circle at 2 points. So it is not possible to draw. So if saying like this, if a point lying inside the circle, so it's not possible to draw a tangent which pass through this point. So it's not possible to draw any tangent to a circle through a point inside it. So its meaning is what? Its meaning is this: we cannot draw any tangent through a point if the point is lying where? Inside the circle. Understood? Next, this is given in this figure. First figure is this. So what's the name of this figure? We can say this first figure according to this. In your book given, see figure 10.6 first part. So next, take a point on the circle. On the circle meaning boundary of the circle. So we are having a circle like this, and point we can take where? On the boundary of the circle. It's not compulsory here you can take. You can take anywhere, but that point must lie where? On the boundary of the circle. So it's written next, take a point P on the circle and draw tangent through this point. So we will draw line segment which pass through this point. So if we can, if we can draw, all are intersecting this circle at how many points? Definitely 2 points. Only one line which pass through this point and intersect the circle, or we can say touching the circle at only 1 point. So next, take a point P on the circle and draw tangents through this point. You have already observed that in the previous section of this chapter. If we can draw one tangent possible, and if we can draw any other, that one is definitely what? Secant of the circle, or secant of the circle mean chord of the circle, you can say. So is only one tangent to the circle at such points. So if first condition, if point lying inside the circle, it's meaning there is no tangent possible on that circle. If point lying on the boundary of the circle, then one tangent is possible. And one more case left. Which one case? If point lying outside the boundary. Where lying? Outside the boundary like this. This is a circle and point is this anywhere outside, here, here, anywhere. So then how many tangent we can draw? So then we can draw 2 tangent. Then how many tangent we can draw? 2 tangent, which is given on your next portion of this match. Finally, take a point P outside the circle. So this is a circle. This is a circle, and we are having point here, here, anywhere you can take. And if you can draw a line segment which pass through this point, touching the circle. So how many tangent possible? 2 tangent possible. Later on, this we can prove length of these tangent also equal. Understood? So it's written, finally take a point P outside the circle and try to draw tangent to the circle. From this point, what do you observe? You will find that you can draw exactly 2 tangent to the circle. How many tangent through this point? So again I can tell, if we are having a circle and point lying inside the circle, it's meaning we cannot pass any tangent through this point. All are secant or chord of the circle. If the point is lying on the boundary of the circle, then only one tangent pass through this point. And if the point lying outside the boundary, then we can draw 2 tangent which pass through this point. So we can summarize these facts as follow. It's given that I told you, case number 1, if point lying inside the circle, there is no tangent to the circle passing through the point lying inside the circle. Case number 2, there is only one and only one tangent to the circle passing through a point lying on the circle. And if third case, that this is the third case, exactly two tangent to the circle through a point line outside the circle. Actually, we will read in this chapter, we will understand in this chapter what? Property of tangent. Property of tangent. So you understood, I think. So this figure given here, so in figure 10.63, T1 and T2. This is, its name is tangent, this name is T1, its name is T2, and point is lying outside. It's not compulsory, this point we have to take, we can take here also, then also we can draw, then also two tangent. Here we are taking, then also how many tangent pass? Two tangent. So T1 and T2 are the points of contact of the tangent PT1, and later on we will prove PT1 equal to PT2. The length of the segment of the tangent from the external point P and the point of contact with the circle is called length of the tangent. So what's saying? The length of the segment, this is a segment, this is known as the length of the tangent. So that's why written the length of the segment of the tangent from the external point P and the point of contact with the circle is called length of the tangent from the point P to the circle. Note that in figure, in which figure? This figure. PT1 and P2 are the length of the tangent from the P to the circle. The length PT1 and P2 have a common property. Both are having common property that already I told you, PT1 equal to PT2. Later on we can prove this with the help of a theorem. Here also written, can you find this? Measure PT1 and PT, are these equal? You can do this activity also. You can take a circle and take point outside, draw these tangent to the circle. This point name P, its name is T1, its name is T2. You can measure their length. So their length are equal. So it's not by chance. Later on we will prove with the help of theorem also. So let us give a proof of this fact in the following theorem. So one theorem given, important theorem, use of this theorem in this chapter. So what's theorem? The length of tangents. The lengths of tangent drawn from an external point of a circle are equal. So here in this figure we have taken this point outside the circle and we draw this. One tangent is this, which is touching the circle at point Q. Another tangent also which touching the circle at what point? R. So we have to prove here PQ equal to PR. So how can you prove? First we will write given. What we will write? Given. Let P is the point lying outside the circle. Outside the circle, having center whose circle O. Draw a line or line segment which touching the circle at point Q and R. Q and R. To prove, what we have to prove? PQ is equal to PR. And then what? Proof of it. Proof of it, meaning join P and O. Join P with O. P with O. Then how can you solve? How can you solve? This angle, you know how much degree? 90 degree. This angle how much degree? 90 degree. So in triangle, which triangle? POQ and triangle POR. Both triangle we have taken. So what we can say? PO equal to PO. What's common in both? What's common in both triangles? We are using here congruency rule. What's OQ is equal to OR. What is radii? Radii is the plural of the circle. What's plural? Whose plural? Radius. So these both are the radius of the same circle. And angle PQO equal to angle PRO, each 90. Each angle how much degree? 90 degree. Yes or no? So by which rule? By RHS, congruence rule. What's RHS saying? R mean right angle, H mean hypotenuse, S mean any one side. If one angle is 90 degree in both triangle, hypotenuse also equal in both triangle, then any one side you can, if you, with the help of, by applying any method, you can prove any one, either base equal to base or perpendicular equal to perpendicular. Then the two triangle are congruent. So if this is 90 degree, so definitely this one is the hypotenuse. So by RHS, what we can say? Triangle, which triangle? POQ is congruent to triangle POR. Both triangle are congruent. So by simplicity, what you can say? We can say PQ is equal to PR. Hence, length of the tangent drawn from the external point of a circle are equal. So written, the length of a tangent drawn from an external point of a circle are equal. So this easy theorem, if you can understand this, easily able to solve question given in the exercise. So now this example given, we will start this example also. Prove that the two concentric circle meaning having same center. So here two circle in the figure, C1 bigger circle and C2 smaller circle name given. Prove that the two concentric circle, the chord of the larger circle. So which one? This is the chord of the larger circle, touching the circle at 2 point. Which circle? Bigger one, C1, and touching the circle C2 at only 1 point. So it's meaning this AB is tangent to the circle. Which circle? C2. And AB is the secant to the circle C1. Now read next part. Which touch the smaller circle is bisected at the point of contact. It's meaning you have to prove AP equal to PB. AP equal to PB. You can take like this, you can join this. You can join this. Understood? Given you can write, what's given? Two circle having center O are C1 and C2. AB is the tangent to the circle. Which circle? C1 and secant to the circle C2, join AO and OB. To prove, show many proofs. AP equal to BP or PB, both are equal. So here is proof. What's proof? In triangle OPA and triangle OPB, OP equal to OP, what's common? Yes or no? OA equal to what? OB. Angle, which angle? OPA equal to angle OPB, each 90 degree. Again by what? RHS, by RHS congruence rule. Triangle OPA is congruent to triangle OPB. So what we can say? Therefore, AP equal to BP. Hence result. Understood? Which thus the smaller circle is bisected. Bisected meaning divided into two parts, two equal parts, sorry. Understood? This important question, possibility coming in exam, according to me, two tangent. So one tangent is this, another tangent is this. TP and TQ are drawn to a circle with center O. We are having a what circle? What circle? O. This is a circle. Having center O. From an external point T, this is a point T. We have to prove that angle PTQ. What's angle PTQ? Angle PTQ is equal to twice of angle OPQ. OPQ. This angle is what's 2 times of it. So look, solution. What solution? What you can say? In triangle TPQ, TP equal to TQ. The tangent drawn from the external point of a circle are equal. So what you can say? Therefore, triangle TPQ is an isosceles triangle. And this we know, but angles opposite to the equal sides of a triangle are equal or not? So what's its meaning? Angle TPQ is equal to angle TQP. Understood? This we can use in our paper in next part of this. So that's why saying number 1, This also we know, sum of angle of a triangle is how much degree? 180 degree. Angle PTQ plus angle TPQ plus angle TQP. How much degree? 180 degree. But these both are equal. So we can write like this. Angle PTQ plus twice of angle TPQ is how much? 180 degree. Take this and that side. Twice of angle TPQ is equal to 180 degree minus angle PTQ. So what's your angle TPQ? Is equal to, if you can divide this with 90 minus angle PTQ by 2. Yes or no? Leave this also here, we will use it. Understood? So here I am writing here angle TPQ plus angle, which angle? OPQ, this also 90 degree. This also 90 degree. So put this value of TPQ here. So 90 minus angle PTQ by 2 plus angle OPQ is equal to 90 degree. This 90 cancel this 90. This taken that side. So angle OPQ is equal to angle PTQ by 2. Transfer 2 in that side. So twice of angle OPQ is equal to angle PTQ. So what we can say? Angle PTQ is equal to twice of angle OPQ. Hence result which we get. So what's major step in this question? Step number 1, we have to use theorem TP equal to TQ. Next step, angle TPQ is equal to angle TQP. Then sum of angle of a triangle is how much? 180 degree. So convert this angle in this form and then write this angle in this form. And this also we know sum of this angle is how much degree? 90 degree. How much degree? 90 degree. If you can understand that, then easily you can solve it. So what's step number 1? This. Step number 2, it's become a isosceles triangle. If it is an isosceles triangle, this angle equal to this angle. From this came this. Then sum of angle of a triangle is 180 degree. This plus this 180 degree. So this angle find out. This angle find out in the form of this. These both are equal, so it's become twice. So this written and this equal to this. And but we know this plus this is how much degree? 90 degree. So put the value of this angle in the form of this angle. You will get result. So step number 1, step number 2, angle sum property. Angle sum property of a triangle. Step number 3, find the value of this angle in the form of this. Step number 3. Step number 4, put the value this plus this 90 degree, put this value of this angle in this form. Then coming the relation between this angle and this angle, you will get your result. Understood? I think one more given. One more given. PQ is the chord of length 8 centimeter. This is the chord given of this chord. How much? 8 centimeter of a circle. Radius of the circle is 5 centimeter. How much? 5 centimeters. Tangent at point P, this is the tangent to the circle. And this one also tangent to the circle. So saying PQ is the chord. So this is a chord of a circle of radius how much? 5 centimeters. The tangent at P and Q intersect at point T. T is the common point which lying the outside of the circle. Find the length of TP. What you have to find out? TP. So find out TP. So here two methods. What methods? Two methods. One is by this you can prove these triangles are similar. How can you prove? These two triangles are similar. Otherwise, you can apply Pythagoras theorem. So, by which method? So, by similarity rule I can tell. By similarity rule. Which triangles are similar? First solution. In triangle PRO, angle PRO is equal to 90 degree. So this is a right angle triangle. So opposite to its base. And what's PR? PR equal to half of PQ. Half of PQ. PQ equal to 8 by 2. How much? 4 centimeters. How much? 4 centimeters. So what is this? So in triangle PR square plus what? RO square is equal to PO square. Understood? PR 4. This we have to find out. RO square, OP 5 square. So RO square is equal to 25 minus 16 is equal to 9. So what's your RO? R equal to under the root is equal to plus minus 3 and length is always positive. So what is this? 3 centimeter. 3 centimeter. What we have to find out? So take in triangle, which triangle? TPO. And this TR we can take X. So in triangle TPO, right angle is what? This one is the right angle. This one is the right angle. So what's TO square is equal to TP square, which we have to find out, plus OP square. What's your OP? So TP is what? This is X plus 3 whole square is equal to TP we have to find out TP square plus OP 5 square. 5 square. So this is X plus 3 whole square minus 25 is equal to TP square. Leave this as it is. Then which triangle you can take? One triangle is this. So another triangle which you can take? We can take this. This also we can take. In triangle Which triangle? TPR. TPR. How much angle TRP equal to 90 degree? So what's TP square is equal to TR square plus 4 square. What's 4 square? So what's your TP? TP square equal to TR x square plus 16. This is number 2. Compare first and second. So x plus 3 whole square minus 25 is equal to x square plus 16. Solve it. X square plus 9 plus 6x minus 25 minus x square minus 16 equal to 0. So this cancel this. So 6x is this. Understood? 25, 41 minus 9 minus 32 is equal to 0. So 6x is equal to 32. So what's your x? X is equal to 32 by 6. How much? 16 by 3. What's coming? X 16 by 3. So what's your TP? From here find out now. Put the value of x. TP square is equal to 16 by 3 whole square plus 16 by 1. This is TP square. Sorry. What is this? TP square is equal to 16 into 16, 256 by 9 plus how much? 16 by 1. So what's your TP square? So what's your LCM? 9 is our LCM, 256 plus 16, 9 is 144 is equal to 400 by 9. So what's coming? TP square is equal to 400 by 9. So what's your TP? TP is equal to plus minus 20 by 3 if you can take under the root of it. But length is always positive. So what's your TP? 20 by 3 centimeter. If meter given. So 20 by 3 centimeter. This is the one method. Another method also, by using two triangles are similar, then we can find out. So today not possible that. In next time I will tell that method also, because I have taken so much time. So I think you understand. Both method I can tell, one method left that I can tell in next lecture. And you can use any method which is easy for you. So thank you for all of you. Best of luck.